Climate Explained. Did atomic bomb tests damage our upper atmosphere? This is by Brett Carter, Senior Lecturer, RMIT University, Reza Pradipta, Research Scientist, Boston College, on The Conversation. I recently read an article stating the atomic bomb testing in the Pacific destroyed so much of the upper atmosphere that the U.S. could no longer bounce communications off the atmosphere and had to deploy artificial satellites for communication. Is this true? And just how much damage did they do? That's the question. The article the question refers to does not mention satellites, so let's focus on the atmospheric damage part of the question. Indeed, surface and atmospheric high-altitude detonations of nuclear weapons can have short-term and long-term effects. One short-term effect was a temporary blackout of long-distance high-frequency HF radio communication over the surrounding area, but this radio communication blackout was not a result of the nuclear explosion destroying the ionosphere. On the contrary, the nuclear detonations temporarily increased the natural level of ionization in the upper atmosphere. The ionosphere and radio communication. The Earth's ionosphere is a natural layer of charged particles at approximately 80 to 1,000 kilometer altitude. This ionized portion of the Earth's upper atmosphere largely owes its existence to solar radiation, which strips electrons from neutral atoms and molecules. The ionosphere consists of three major layers known as D, E, and F layers. The D, lower, and E layers, the lower D and E layers typically exist only during daylight hours, while the highest F layers always exist. I didn't even know that. How could they just disappear during dark hours without daylight? So the lower D and E layers typically exist only during daylight hours, while the highest F layers always exist. And the F layers are around the 300 kilometer mark, as we see there, about 260 to 300 kilometers mark. Now, these layers have distinct characteristics. The E and F layers are very reflective to high-frequency HF radio waves. The D layer, on the other hand, is more like a sponge and absorbs HF waves. In long-distance HF radio communications, the radio waves are bounced back and forth between the ionosphere and the Earth's surface. This means you don't need to establish a line of sight for HF radio communication. Isn't that something? Many applications, such as emergency services and aircraft maritime surveillance, rely on this mode of HF radio propagation. But this radio communication, it's like a dome. But this radio communication scheme only works well when there is a reflective E or F layer and when the absorbing D layer is not dominant. During regular daytime hours, the D layer often becomes a nuisance because it weakens radio wave intensity in the lower HF spectrum. However, by changing to higher frequencies, you can regain broken communication links. The D layer may become even more dominant when intense X-ray emissions from solar flares or energetic particles are impacting the atmosphere. The absorbing D layer then breaks any HF communication links that traverse it. Bomb blasts in the ionosphere. Bomb blasts in the ionosphere. Nuclear detonations also produce X-ray radiation, which leads to additional ionization in all layers of the ionosphere. This makes the F layer more reflective to high-frequency radio waves, but alas, the D layer also becomes more absorptive. This makes it difficult to bounce radio waves off the ionosphere for long-distance communication soon after a nuclear explosion, even though the ionosphere stays intact. Beyond additional ionization, shock waves from nuclear detonations produce waves and ripples in the upper atmosphere called atmospheric gravity waves. These waves travel in all directions, even reaching the ionosphere, where they can cause what are known as traveling ionospheric disturbances, TIDs, which can be observed for thousands of kilometers. Other atmospheric disturbances. Bomb blasts are not the only things that cause disturbances in the atmosphere. In September 1979, there were reports of bright flashes of light off the South African coast, igniting theories South Africa had nuclear weapon capabilities. Analysis of ionospheric data from the Arecibo Observatory in Puerto Rico confirmed the presence of waves in the ionosphere that corroborated the theory of an atmospheric detonation, but whether the detonation was artificial or natural could not be determined. The reason for the ambiguity was that meteor explosions and nuclear detonations in the atmosphere both generate AGWs with similar characteristics. The 2013 Chelyabinsk meteor explosion in Russia generated waves in the ionosphere that were detected all across Europe and as far away as the United Kingdom. Volcanic eruptions, such as the 1980 Mount St. Helens eruption in the US, and large earthquakes, such as the 2011 Tohoku earthquake in Japan that gave us Fukushima, are other examples of energetic processes at the ground impacting the upper atmosphere. Another well-known source of ionospheric disturbances is the geomagnetic storm, typically caused by coronal mass ejections from the sun or solar wind disturbances impacting Earth's magnetosphere. Satellites as backup. In summary, nuclear detonations can impact the upper atmosphere in many ways, as do many other non-nuclear terrestrial and solar events that carry enormous energy. But the damage, so to speak, is not permanent. Did the impact of these nuclear tests on the ionosphere specifically lead to the immediate launch of communication satellites? Not directly, because the impacts were temporary, but in the Cold War setting, the potential for adversaries to even briefly interrupt over-the-horizon communications would certainly have been a motivating factor in developing communication satellites as backups. So I didn't know this, that the fact that during the daylight hours, the ionosphere D and E layer are there, but they're not there during the dark, the hours of darkness. So this is on the conversation by Brett Carter and Riza Pradeepa, scientists concerning all this on the conversation. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.